Hello, everyone. Hope you're doing well today. So, today we move on to the appendicular skeleton, the appendages. The part of the skeleton is more associated with long bones and movement. So, again, when we think appendicular skeleton, think your appendages, your upper and lower extremities. These are the bones that basically help you move through the environment and interact with the environment. Now, we'll begin with the upper extremity. The shoulder girdle. The shoulder girdle is basically where your upper extremity attaches to the trunk of the body, and that is comprised of two bones: the clavicle, which is your collarbone, and then your shoulder blade, which is called the scapula. So if we look at this image here, it's nice because you see part of the axial skeleton, like the rib cage, and there's the arm. But the two bones of the shoulder girdle include the clavicle, which basically helps hold the scapula away from the body, and then the scapula, to which your arm attaches. Okay. Now, if we look at the scapulae or the shoulder blades, most of what holds them in place are muscles. So we have muscles that hold that bone, the shoulder blade, in place. And the cool thing about that is because it's mostly held in place by muscles, you can move your shoulder girdle around pretty freely. You get greater range of motion. Okay. So the idea is if your arm is going to be attached by something, having a movable shoulder girdle increases your range of motion. So we have greater freedom of movement because most of what holds your scapula in place is muscle. The only thing that actually holds your shoulder girdle to the trunk of your body is the clavicle. The clavicle is that one bone that sort of braces the scapula and holds it away from the body, and then it attaches to the sternum. So you can feel sort of the sternoclavicular joint where your clavicle attaches to your sternum. All right, let's see. The scapula has two processes, two bony extensions that we want to learn. There's the acromioclavicular joint, or the acromion process, and the coracoid process. So if we bump back here, it's sort of tough to see, but the scapula, like your shoulder blade, it has a little bony extension that comes around to the front, and you can actually feel that in your shoulder. So if you move your shoulder up and down, you feel that bump. That's the AC joint. That's the acromioclavicular joint. So that is right here. So the acromion is this extension of bone that you feel on the bump of your shoulder. And then beneath that is the coracoid process. This is a really deep process. That's where part of your biceps muscle attaches. So your biceps attach in part to this coracoid process, this bony process deeper in your shoulder. Let's see. Another prominent feature of the scapula is the glenoid cavity or the glenoid fossa. So this is the little divot in here. That's where the head of the humerus attaches. So it's sort of like a shallow cup in the scapula that connects to the humerus. So again, the scapula is pretty freely movable because it's mostly held in place by muscles. Its only other attachment to the trunk of the body is by the clavicle. So your shoulder blade is pretty movable. Let's see. Now, there's this sort of tug and push and pull with stability and flexibility. You can have greater stability with bone, but you're going to give up range of motion. Or you could have greater range of motion, but you're going to give up stability. We have a really movable shoulder girdle, so our shoulders have a lot of flexibility. But because of that, we have a relatively shallow glenoid cavity in the scapula, so it's easier to dislocate your arm. Sometimes people get a hit on the top of the shoulder. It can push the head of the humerus out of this cavity, and then people have a dislocated shoulder. Additionally, because the only thing holding your shoulder to the trunk of the body is this sternoclavicular joint, that can also get dislocated. So if people fall and hit the outside of their shoulder, that can dislodge that connection. Okay, looking at the upper extremity. Now, a lot of times people refer to this whole extremity as your arm. Technically, your arm is just your humerus, and then this is your forearm. So the best way to do this is refer to this as our upper extremity. So the arm itself is, again, one bone, the humerus. The humerus has a head with these tubercles or tuberosities, these bumps on them. Now, we know that when you see bumps on bone, that's where muscle attaches, right? So you have these tuberosities that we see here. That's a site of muscle attachment. You see the rounded head that fits in that glenoid cavity of your scapula. The surgical neck, this is sort of interesting. This is sort of a structural weak point in the bone. And this is relevant because a lot of times people get bone breaks in their long bones. I remember when my son broke his wrist a number of years ago, I asked the orthopedic doc if there should be any concerns about damage to growth plates. And he was like, well, no, actually, the surgical neck is inside where the growth plates are, and it's sort of a weak spot. So if the bones break, they tend to break in the surgical neck rather than getting damage done to the growth plates. So it's something that sort of prevents damage from long bones that would inhibit their growth, but it is sort of a weakened point in a long bone or in the humerus. Let's see. This deltoid tuberosity, this is a bump on the outside of the humerus. This is where the deltoid muscle attaches. The deltoid is like a cap on your shoulder, and it dives down and attaches at the deltoid tuberosity. If you lift your arm to the outside, you can start to feel where the deltoid muscle inserts into your humerus. And down at the distal end, you have a couple of bony marks. It's the trochlea and capitulum. The capitulum is sort of like a dome, and the trochlea is sort of like a spool. I don't know if you've ever seen spool for yarns. It's wider on the outside and narrower in the middle. And that is a bone that your forearm attaches to, or those are extensions of bone your forearm attaches to. Now, getting into the forearm, you have two bones, the radius and the ulna. The radius is on the thumb side, and the ulna is on your pinky side. The way I was taught this, you turn on the radio with your radius, the thumb side. So if you turn a knob, I guess people just push buttons or tell a device to do it now. But if you had to ever turn a knob, you turn with your thumb, and that's where the radius is. Okay. Let's see. The radius and ulna are connected in two spots. They're called radial-ulnar joints. And in between them, they're connected by this membrane, and it's called an interosseous membrane. Inter means between, osseous is referring to bone. So they're connected by this, tough connective tissue. Let's see. On the radius, you get a radial tuberosity, that bump there. And again, that is where your biceps attach. So your biceps attach up in your shoulder, and then they attach to your radius. And then what happens is when they contract, it shortens the span in this joint. Okay. Another interesting feature of the ulna is what's called this olecranon process. The olecranon process is a C-shaped extension of bone. So if we bump back to the trochlea here, you see how the trochlea is narrower in the middle and wider on the outside. Well, the C-shaped trochlea fits in there. So you can feel the olecranon process in your elbow. So that's the curved part of the elbow, and it attaches to your humerus. And what that does is it gives you what's called a hinge joint. You can open and close your elbow. Let's see. Now moving into the hand, we have different sort of sets or series of bones. There are your carpal bones, which are your wrist bones, the metacarpals, which make up the palms of the hand. Think meta means center. And then your phalanges are your fingers. All right. So the wrist, again, it's made of these carpal bones, which are short bones. They're the little square block-shaped bones, and they're stitched together by ligaments, so you don't get a lot of movement in your wrist. That, again, it's more for stability. Okay. So when we look at our appendicular skeleton, it's mostly long bones, right? But then we also have short bones in the wrists and ankles. And again, we give up some flexibility there for stability. The metacarpals make up your palm. And again, they are long bones. It's sort of weird to think about the bones in your palm being long bones, but they are. Okay. And then we finish with phalanges. You have 3 phalanges in your digits, except for your thumb, which has 2 phalanges. And again, you think about that, there are fewer joints there, so we have less flexibility, but we have greater strength and stability in the thumb. But again, we've got multiple joints there to allow you to grasp things more precisely. By having all these joints at the end of this limb, it gives us the ability to reach out, but then to touch with dexterity. We can handle things with greater dexterity. That's pretty cool. All right, that's it on the upper extremity. We'll finish this looking at the lower extremity. So thank you very much.